Hey guys, Mike Build. In today's video, I'm going to show you how to build a very simple and budget-friendly solar power system that you could use for camping, charging devices in case you lose power at your house, or maybe you want to learn more about solar power and want to dip your feet into it but not really sure where to start or what components to buy or how to even hook it up. I intend to make it very beginner-friendly so you guys at home can literally follow along step by step, and by the end of it, you'll have a working solar power system. It's equipped with a pure sine wave 12-volt inverter, 500 watts. We have an MPPT solar charge controller. We have DC bus bars. We have a DC fuse block. That way you can hook up things like these little USB chargers or 12-volt chargers or anything like that on 12 volts. It's also equipped with a 12-volt, 100 amp hour lithium iron phosphate battery with a smart BMS inside of it that has Bluetooth, so you can connect your phone to it to monitor everything on the system. And then to charge everything, we have a 100-watt solar panel. The components for the system I picked specifically to be as budget-friendly as possible, but also be somewhat reliable, something you can use for a long time. And even if you never upscale it from here, these are all, in my opinion, pretty good components to start with, and it'll at least get your feet wet in the solar game. If you wanted to ever upgrade any of these in the future, you could very easily scale this up with a lot of the existing equipment, and that's it. In a future video, we're actually going to build a way bigger system, and I'm going to show you how to power an AC unit. This one, because it's only 500 watts, is going to be good for chargers, lights, TVs, small appliances like that. Nothing crazy big. If anything, you can use it for if you have a power outage at your house, camping, or anything really like that. So now I'm going to take you guys to the table, and I'm going to show you each component one by one, and we're going to kind of talk about each component. I'll explain the differences, what's on the market, and then we're going to build this whole thing from scratch. And my intent, if you guys finish this video through the end, is to make you guys at least basic solar experts. Hopefully with the knowledge you guys get from this video, you won't be scared to touch the solar stuff and actually give it a shot and learn anything we can learn together. I'll show you guys all my tips and tricks on how I did this. Hopefully we can be successful together. As far as cost wise, we're in this thing for less than 450 bucks, and that includes the battery, that includes all the wiring, that includes all the components you see, the solar panel and everything. And that is still a lot of money. However, if you look at the value you get for the components I sourced out, you're actually going to get a pretty good deal. I tried to use high-end but still budget-friendly components in the system to keep the price as low as possible. And honestly, you guys could get this price even lower if you maybe didn't use one of these fuse blocks right here. If you used a little bit cheaper battery, there is things you can do to make this a little bit cheaper, but this is what I would consider still a pretty good budget setup that is very capable. It's scalable. We have this mounted to a piece of wood right now, literally just for visuals to help you guys kind of visualize how it's wired, but you could very easily take all this and put it in a box. In fact, I might do that in a future video, maybe try to make this as compact as possible. And that's it, guys. After we're done going over all the components and building it, we're actually going to take it outside. We're going to show you guys it charging off the solar panel, show you guys how fast it'll charge this battery, and then we can run a bunch of different devices. I'll show you guys what you can do with 500 watts, and we'll wrap this up. I have everything we need to build our solar power generator, solar power station laid out right here, including all the special tools and common tools right here. Now, because this video is geared more toward beginners, I'm going to kind of go over each component and tool step by step and kind of explain a little bit about it. So for some of you more seasoned solar techs or people who know a lot about this, it may seem kind of boring, but this is geared more toward the beginner. So if you're more of a beginner and you just kind of want to learn and see what the tools of the trade are as far as doing this kind of stuff and what the components are and how they work, this should give you a lot of good information. So first we're going to start with each component one by one and then work our way to the tools. All right, guys, first we're going to go over the battery. You can think of the battery as like your fuel tank. So the bigger your battery, the more fuel you can hold in your tank and the longer you can run your devices for. This particular battery is a 100 amp hour lithium iron phosphate chemistry battery. As far as batteries goes, the most common chemistries you'll see is lithium iron phosphate, and lead acid. Lead acid is kind of older tech that's very reliable. You don't need a whole lot to look after it, but it does have its drawbacks considering the fact that it's way heavier. The cycle life is significantly less on a lead acid. You'll be lucky to get a few hundred cycles, if even that, out of even a really, really high-end lead acid battery. And you also cannot deeply discharge them reliably without causing damage to the batteries. Even the deep cycle batteries, you don't really want to go past like 50% if you're going to use them for long-term storage. Whereas these lithium iron phosphate batteries are getting so cheap and so reliable, and you can easily discharge these all the way down to 100 and back up to 100, and they do not care. The cells inside of this, they rate for 4,000 charge and discharge cycles. As far as what brand to get, I'm going to leave that up to you guys. There's a lot of cheap ones on the market and there's a lot of expensive ones on the market. My personal choice would be something kind of in the middle. This particular battery has a Bluetooth BMS. That way you can connect your phone to it, see the state of charge of the battery, and if you're going to use just this and no other sort of meters on your system, it's a good way to kind of keep track of the power going in and out of the system and how much power you have left in the battery. And as you guys can see, we are connected to the battery right now with the phone app, and it gives us a little fuel gauge and it gives us the temperature, the voltage, and all the things you would want to know about what's going on in your solar power system. A lot of the times as well, the battery is going to be the most expensive part of your system, and generally speaking, the more storage you want, the more batteries you're going to need. For this specific example, we're only going to be using one battery to keep the cost down, to keep it simple, and this is only going to be a 12 volt system. If you want to scale up to higher voltages to run bigger loads, you are going to need more batteries, or you're going to need higher voltage batteries. Now, if you're wanting to add more batteries to your system, or you're maybe not quite sure how much battery you're actually going to need, the first thing you need to do is determine how much your load is going to use. So for simplicity's sakes, I'm going to give you guys kind of an easy example to follow. Let's say we need to power a 100 watt load. The load will use 100 watts continuously. Each of your 100 amp hour 12 volt batteries is 1280 watt hours. If you take 1280 divided by 100, you will get 12.8. So in theory, you'd be able to run your 100 watt load for 12.8 hours. Now, that is not ideal because you do have efficiency losses in the inverter itself. So what I would always do is take that number and I would actually underrate it just slightly to give yourself a buffer. So I would say if you want to run a 100 watt load for 12 hours straight, this would probably be able to do it, and you'd have a tiny bit of a buffer. And that's also including no sun coming in. If you have solar coming in, obviously that number will be better because you'll be offsetting what you're using with the solar panel. The next component in your solar power system is going to be the solar charge controller. And what this is going to do is take the power from your solar panel and regulate it to the battery system that you're going to be running. Because you cannot hook the panel directly to the battery, this is going to be between the two, and this is going to control the charging, regulate it, and do all that good stuff for you. That way you don't have any issues with that as far as overcharging the battery or not providing it with the correct voltage or amperage. This will do everything for you. And this particular one is what's known as an MPPT, and that stands for multi-point power tracking. These are generally regarded as the most efficient, and it's a far superior technology compared to PWM. And that's the controller we're going to be running. Here is a similar priced PWM controller. Both of these controllers run about 40 bucks, but the good thing about this PWM controller is it can actually take more voltage and a little bit more amperage, versus this one, it can take a little bit less, but this does have the better MPP tracking technology. This is a standard PWM or pulse width modulated, and normally you'll see these at a lower price point. It is cheaper to get one of these, and there's nothing wrong with these inherently. They do work as designed. In fact, I bought one to test and mess around with. For what these cost these days, you can always spend just a little bit more money and get an MPPT solar charge controller, and that's going to give you just a little bit more efficiency out of your solar panel. It's going to give you power earlier in the day when the sun's not as bright, and later in the evening when the sun is starting to dim a little bit more versus a PWM. If you can spring for it, always try to get your MPPT controller, but the PWM ones also work just fine. The next part of your system is going to be your power inverter. So we have right here is a BeastTech 500 watt pure sine wave inverter. This one is rated at 500 watts, but it doesn't appear to have a surge rating, but you do have to be careful because a lot of inverters on the market, they will rate whatever rating they put on the front is going to be the surge rating, but the continuous rating is sometimes a little bit lower. So do keep an eye on that. As far as inverters go, the two most common you're going to see when shopping around is modified sine wave versus a pure sine wave. Always just spring for the pure sine wave. It's a better technology. It's easier on electronic devices. And honestly, once you start getting into bigger, more powerful systems, they're all going to be pure sine wave anyways. So I wouldn't even waste your money on a modified sine wave inverter. What also could happen is if you plug a device into a modified sine wave and it's extremely sensitive to the power, you may actually end up damaging the device you're plugging it into, and you don't want to have to deal with that. So always just spring for a pure sine wave inverter. As far as the size of your inverter, you're going to want to size it for the type of loads you want to run. Because we're building a budget-friendly system, I went with a budget-friendly inverter. This inverter costs about 50 bucks. If you're willing to spend more money, I would go, you can go 1,000, 15, or even 2,000 watts, and you'll be able to power much more devices. And essentially the job of the inverter is to take the 12 volt power or battery power on these terminals right here, and it's going to convert it into 120 volts, just like you could plug in your house appliances. So you can see on the front of this one, we also have some USB ports, we have an on-off switch, and we have a status light. And then on the back, we have a fan, we have your input, and then we also have some fuses. So that's nice to see. The entire case of this thing is aluminum, feels very nice. So this will work really well for your first beginner solar power system, and it'll just give you clean, reliable power for all your devices under 500 watts. And inverters come in all kinds of shapes and sizes. This inverter right here is a 6,000 watt inverter capable of powering most loads on your house. We also have this inverter here. This one is similar to this one to where it only takes 12 volts, but this is capable of doing 3,000 watts instead of 500. And this is also a low frequency inverter. So as you can see, the size is much bigger. This thing is also much, much heavier. It uses a little bit more idle consumption as well. When the inverter is just turned on, not powering a device, you will use more power. And this is also capable of high surge loads. That's why you would want to go with a low frequency inverter if you're trying to run big things with motors and things like that. Now, the next component I'm going to talk about is a DC power distribution block, kind of like this. This is mostly used in marine and automotive applications. What this allows you to do is put your 12 volt sources here, and it gives you a bunch of fused outputs to connect like anything 12 volt, lights, chargers, things like that, that you don't have to go through the inverter to use, because you do get a little bit of efficiency loss going through the inverter. So if you hook it directly to 12 volts, you can generally get a little bit more efficiency. So this would be good for any sort of car chargers, phone chargers, just things like that. And with this particular block here, these are very cheap. It gives you a fuse That way it's already fused and safe, and then all you have to do is connect your power and your ground straight to this and you won't have any issues. So I'd recommend if you're building a small setup, I always add one of these because it makes it easy to add your extra devices. As far as connecting everything together, you're gonna need wiring and you're gonna need some sort of bus bar. So I always recommend using a set of bus bars. I love using these on Amazon. I actually use this on all my systems that I build because it makes adding, connecting, and disconnecting load switches and all that stuff very easy. It's just a normal set of bus bars. So these have little terminals for smaller wires and it has these big lugs for big copper lug wires, main power wires, and things like that. Always love to use these. It makes hooking everything up way easier. Something else you're also gonna wanna add is a fuse. As far as fusing your system, you wanna take the maximum power of your system and fuse it to about that size. So for example, in our situation, we're gonna be using a 500 watt inverter. If you take 500 watts, divide that by the working voltage, which is 12.8, it's going to give you approximately 40 amps, I think about 39 amps. So we're gonna fuse this to a 50 amp just to give it a little bit of leeway. And this is gonna protect the system from, if the inverter shorts out or something shorts out, something happens, this will blow before you melt or damage any of your other equipment or potentially cause a fire. So it's always a good idea to fuse your equipment. As far as wires, we're going to use 8-gauge wires to connect the inverter and the charge controller to the bus bars, and then connect the battery to the bus bars and to our fuse. We're gonna use 6-gauge wires. I'm gonna put a link to all these wires down below. I always buy long lengths of wire on Amazon. If you're gonna buy wire, make sure you do not buy copper clad aluminum wire because that stuff is junk in my opinion. Some people have had luck with it. Personally, I would avoid it because it's just too easy to get corrosion and a bad connection, and a bad connection always equals heat, and you guys don't wanna have to deal with that. So I always buy my own wire. I always make my own leads. And I actually have a separate video on how to make leads just like this. These are nicely crimped, as y'all can see, and they are marine heat shrinked, so they are water resistant as well. So these main 6-gauge wires are gonna be for the battery to connect to our bus bars, and then the 8-gauge wires are gonna connect from the bus bars to our charge controller and to our inverter. As far as what size wire you need for the system that you're gonna be building, if you're building something bigger than 500 watts, I'll put a chart on the screen right now that's gonna kind of reference wire size for the amount of amperage you're gonna be running, and you might need to use a little bit of math to figure out exactly how much you need. I would always suggest whatever size wire it recommends, I would go up a little bit in size as far as thickness, because it's always good to have a little bit of headway versus running a wire size to its absolute limit, because when you do that, you will create heat, and you don't want to create heat. Along with your pure copper wire, you're gonna want copper lugs. Always match the lugs to the wire size. So for 8-gauge wire, it says right here 8 AW gauge. And then for the 6-gauge, same thing. And this actually comes with marine heat shrink as well. And I use both of these on all the wiring you see in this video, and it worked really well. I was very happy with that. I always try to use copper lugs on any wire bigger than like an 8-gauge wire. I don't really like to use butt connectors unless it's really small. As far as the solar panel connecting it to the charge controller, this is some special solar wire. This is rated for outside. You don't want to use normal wire if you're gonna have this in the weather because it will degrade way faster. This is special solar power wiring. On one end we put ferrules, on the other end we're gonna have some MC4 connectors. The MC4 is what most solar panels have and what they plug into. Actually, how could I forget, you guys? I did forget to point out what panel we're gonna be using. We're gonna be using one of these Renogy 100 watt solar panels because we're building a budget system that's only gonna be used to charge devices and small items. We don't need a ton of solar panels. So just to get us started, we have one 100 watt panel, and that should be plenty for what we need right now. Most, if not all, pretty good solar panels on the market will come with MC4 connections on it. So plan on using MC4s. It makes connecting everything very easy. Okay, hopefully you guys are still with me and I'm not blowing through this too quickly. I'm really sorry if I am. Please leave your guys' questions in the comment. If there's something you need more detail on, I just don't want to bore you guys. I want to kind of keep it moving. So next we're going to move on to the tools that we're going to use to build this whole system. One more thing I forgot to show y'all is I'm also a big fan of these little 12 volt to USB little adapters here. These are also for automotive. These run on 12 volts, and this is what we're going to connect to our little fuse block here to be able to charge devices with. I really like these. They make them in a ton of different configurations and a ton of different power levels, and they work really good for charging phones, tablets, anything with a USB port, cameras, anything like that. Really, it works really well. I've used these a bunch in the past and I really like these. Okay, the next section we're gonna go over is all the basic tools that you're gonna need to build this system. The cool thing about some of these tools is they do seem kind of overkill for just this one project, but if you do plan on getting into solar and you do plan on doing a lot of things with solar and energy and batteries and things like that, all these tools can be used for tons of different projects and tons of different sizes. I've used these from this system all the way up to a 6,000 watt system that I currently use to run all my AC units. So this stuff, you buy it once, you cry once, and all of it's actually very affordable, and you can get all of this on Amazon as well. So the first and obvious thing is just gonna be a set of wire strippers. I also like to have a good set of just snips or dike. This makes cutting thicker wires a lot easier. Just some standard hand tools, a Phillips head screwdriver, a small Phillips head screwdriver, and a small adjustable wrench. For this specific project, we're gonna need a ratchet wrench with an 8mm socket in order to tighten the lugs on the DC power bus. This right here is an awesome tool if you're gonna be crimping a lot of big copper lugs. This is a hydraulic crimper with tons of different dies. It can put a ton of force and make really nice, beautiful crimps. If you're gonna be crimping copper lugs on any sort of big wire and you have a bad connection always equals heat. and that is a no-go for any sort of power system at all. So I would highly recommend, if you're gonna be doing a bunch of big power wires, anything bigger than 8 gauge, I would highly recommend investing in one of these hydraulic crimpers. You can normally pick them up pretty cheap on Amazon, between $40 to $60. This one came from Harbor Freight. I've actually had this for probably 5 years, and I've crimped probably hundreds and hundreds of crimps with this exact tool right here, and I've had no issues with it. It's awesome, makes really good crimps. In fact, I did a whole video me using this tool on how to make really nice crimps as well. This is a ferrule crimper. Now a ferrule kind of looks like this, and what it does is you can take multiple strands of wire, shove it in here, and crimp them to make them nice and neat. And kind of like this is what the ferrule crimp looks like. And this is good to put into charge controllers because you don't want all the strands of wire getting shoved into the charge controller. You can sometimes not have a good connection, so I highly recommend using ferrules on these smaller wires like this. It makes wiring up things very easy. And last but not least, this is the MC4 crimper. MC4s are gonna be the connectors used on all your solar panels. This is how you're gonna connect the solar panel to your system itself. If you use these, you'll be able to easily hook up to most solar panels on the market, so you can buy the panel, plug and play. If you wanna add panels, it makes it very easy. They also make tons of extension harnesses and Y harnesses and things like that to be able to add up and stack your panels as you kind of grow. But as far as tools, guys, this is most of what you're gonna need just to do small scale stuff. You can kind of ball out and get more tools than this if you really want to, but honestly, I've been able to do a lot with just this stuff right here. You don't need to necessarily get the nicest ones. I honestly just kind of buy the cheapest one that works, and I've had pretty good luck with doing that. I will put links to all this as well. I'm not gonna be doing too much crimping in this specific video because our cables are made, but if you guys want a specific crimping video, I can absolutely do that for you guys to show y'all how to use each one of these tools. I'd be more than happy to do that. So if that's something you need, just leave it in the comments. And guys, the last tool I forgot to mention that's very handy to have in your bag for anything electric related is a good multimeter. This one's from Harbor Freight. It costs $20, and honestly, even this works just fine. You don't gotta go out and spend $1 million on a nice fluke. If you have one, great, use it, but if not, this little $20 one from Harbor Freight will serve your needs just fine. Now that we've gone over all the components you're gonna need to build your solar power system, now we're gonna mount them to this piece of wood. The reason we're using this piece of wood is to keep it visually easy to see what's going on. Probably in a future video, we're actually gonna take all of this and put it in a really compact case just to kind of make like a way more compact version of this. But just to keep it simple, we're gonna mount it all to this piece of wood, and even if that's what you did at home, I promise you guys it would work just fine. All right, so our charge controller is mounted. We're gonna mount the inverter, and I'm literally just using plain old screws, nothing fancy, nothing expensive or crazy. Okay, so now all the components are connected to the board. They are securely mounted, so we can move this around and nothing's gonna fall off. Now we're gonna go ahead and start wiring everything up. So we're gonna remove our bus bar covers, remove our charge controller little cover here. We're gonna take the leads that we made to go from the charge controller to our battery bus bars. And if you look really closely, this is gonna be where you wire the solar panel. This is gonna be where you wire the battery. And then this is if you wanna wire something to like a light or something. I normally never use this, so I can't really tell you exactly how that works. But on a lot of different controllers, you can use this just to run really small loads, but nothing really crazy. So positive is gonna be your red, negative is gonna be your black. Same with the solar, pretty simple there. I'm literally gonna take my 8 gauge wire. I'm gonna go ahead and shove it in here into the negative side of the battery. And then we're gonna tighten that up. And you want to get these kind of snug, but you don't want to over tighten them either. Just get a good bite. Boom. Give it a little tug, make sure it doesn't come out, and you're good to go. Same with the positive. Put it in the positive terminal for the battery. Torque it down with your screwdriver. We're going to take your wires, just kind of run them nice and neat to your negative and positive bus bars. Bam, just like that, your charge controller is now connected to our main power bus bars. Now we're going to connect the inverter, and we're going to do the same exact thing. Already got our leads pre-made. And make your connections nice and secure. We don't want any loose connections. Red to red, black to black, too easy. Same thing, go ahead and connect this to your main bus bars. And this is why I love using bus bars, because it makes connecting everything super easy. Torque it down. Our inverter is now connected, our charge controller is now connected. We're gonna connect our DC power distribution block. Already made our leads. The last thing we have to do is connect our main 6 gauge power input wires to our battery bus bars. And then I'm also gonna throw some dip ties on the wires to neaten everything up. On the power input, we are gonna add a 50 amp fuse for safety, and this is gonna make sure the whole system is safe. The only other thing I might advise you guys do at home is maybe add a fuse to your solar charge controller. That way this is individually fused. The inverter already has its own set of fuses in there, and then the 50 amp fuse will fuse just the whole system in case you have any shorts, and that'll protect the wiring and all that stuff in case you have any issues at all. But just for this demonstration, we're not gonna put a fuse on this for now just because I didn't have one, but I would recommend you guys do that, and you would wanna fuse it according to what the output is. So if this is a 20 amp charge controller, I would fuse it at, let's say 25 or 30 amps just to give yourself some headway. And same thing with this, red to red, black to black. I'm also gonna go ahead and install our fuse. So we're probably gonna put that right here. We're gonna use this little length of short wire to kind of connect that to give us our input. All right, let's go ahead and get our negative attached. There we go, nice and secure. And the last connection we gotta make is we have to connect our MC4 little adapter harness that we built into the charge controller. And this is going to allow us to connect our solar panel to the charge controller itself. And there we go. Give it a little yank, make sure it's good to go. And that's it. And that is our whole build, guys, from start to finish. As y'all saw, very simple. Anyone could do it. Now, all we have to do, connect our choice of 12-volt battery on this end, connect whatever solar panel we want to that end, and we will be generating power, and then we will also have ways to use the power. I'm gonna hook up this little USB adapter as well, and all this is 12 volts, so that just goes straight to our DC bus bar system. All right, guys, here we are outside. We have our solar generator that we put together. We have one 100-watt solar panel, and we have our battery. So now we're gonna kind of connect everything up. The first thing you wanna do is connect the battery to the charge controller system, and then you're gonna connect the solar panel to the charge controller. It's very important that you do that first because certain charge controllers don't like when you plug in the panel first, it could actually mess something up. So always connect your battery first. Hi, Midnights. And you can see we kind of tidied up the wiring, so we're gonna go ahead and lay all the wiring out. So this is gonna go to our panel. And I always try to make that a little bit longer. That way you can have this away from the sun. Obviously right now it's laying in the sun just for demonstration. So we're gonna take our leads. Battery's all connected up, as y'all can see. The charge controller has also booted up, but right now it's showing a moon because the solar panel is not connected. So let's go ahead and connect that. All right, solar panel's connected. Let's go back to the charge controller and see if we're charging. I don't know how good that's gonna show up on screen, but we are in fact charging. And the MPPT is slowly coming up to power. And we're already at 5 amps going into the battery. That's pretty good. And because we used a smart battery with a smart BMS, we can go ahead and connect it to my phone and we can open the battery app and see if it's charging. All right, guys, there we have the app open and you can see we're putting 73, 76 watts into the battery. We have an 88% state of charge, and it's also telling us how much time we have left to fully charge the battery. And this is the reason why in this particular build, I didn't put any sort of voltage meters or charge indicators or anything like that. The reason I did that is to keep the cost down, but also because we can just use the phone app. In a future build, we will actually be adding one of those. So now let's turn the inverter on and see if we can power some stuff. All right, guys, it's a little warm out here, so I guess I want to use a fan. Come over here and kick our inverter on. Oh yeah, look at that. It'd also be kind of nice to charge my phone because my phone's not fully charged. So we can come down here to our little phone charger USB, turn that on. I don't know how good that's gonna show up, but we have a little voltage display right here. I'm gonna go ahead and plug the charge cable to the adapter, plug our phone in, and we are charging the phone. You know what? I gotta do a little bit of yard work. All right, guys, I gotta do a little bit of yard work, so let's go ahead and charge my mower up, see if it'll handle charging this. A 60-volt battery, and we're charging. So that's it, guys. I'm gonna let my mower charge up while enjoying a nice fan and charging my cell phone, all for free with solar. And for anyone who's curious about how much power we're actually using, 160 watts, so not bad. And we can run this load for 7 hours. We're actually using more than 160 watts total, but you gotta remember we're putting almost 80 watts back into the battery, so it'd be 160 plus the 80 we're using. So it'd be well over, we'd be closer to about 240. I hope you guys got something out of this. If you're a beginner and you wanna get into solar, I do believe this is a very easy and cost-effective way to do it. You could definitely power a wide variety of devices, even though you're only limited to 500 watts by this inverter. I tried to make this as beginner-friendly as possible. Hopefully I did a good job explaining it to you guys, not boring you guys, and showing real-life uses for something like this, and also how compact you could actually build this. And if you put this all in a case, you can make this way nicer, and the sky's the limit from there. But this is just a very bare bones, very basic system that does exactly what you need it to do, and it'll be reliable, it'll last for many years. You could get a ton of use out of this and also build your knowledge of solar and electricity, and it's just kind of a fun project to build, honestly. In a future build, we're actually gonna supersize this, so we're actually gonna go a couple sizes larger on the inverter, the charge controller, the batteries, and everything, add a couple more panels. And the goal with that video is to show you guys what you need to power a window AC. That way in the summertime, you can put a window AC in your house, run it on a system that's bigger than this, and get free cooling inside your house to kind of help offset some of the cooling that your central air has to do. So that's gonna be a fun project. Look forward to that. We're definitely gonna be doing that here soon. As always, I'm gonna put everything you see here in the description of the video. If you guys have any other questions, specific questions or general questions, put them in the comments. I always do my very best to answer them, and I try to be as thorough as possible. So let me know what you guys think of this project. Let me know what y'all would do to improve it, and let me know if you guys have built something similar to this and what you're using it for. I'd love to hear about it. I guess that's gonna do it, guys. I'll see y'all in the next video.